So today, as part of our course on handling values in Java 21, we are going to discuss on StringBuilder. Everything we learned about string immutability earlier, so the rule that every method returns a new object and the original is never changed, StringBuilder breaks every one of those rules, okay, and it does it deliberately. StringBuilder was designed to be the mutable alternative to string. Where string is immutable and every operation creates a new object, StringBuilder is mutable and every operation modifies the same object. There is no new object created. There is no return value you need to capture. The modification happens directly inside the StringBuilder that you already have. So this difference has two consequences. First, it is more memory efficient for repeated modifications. You are always working with one object, not creating dozens of temporary objects like in string. And second, the programming model is completely different. Methods modify in place, so you do not need to reassign. Okay. So let's go to line 1, StringBuilder sb is equal to new StringBuilder hello. So what happens here is that we create a new StringBuilder object. Unlike string literals which go into the pool, StringBuilder objects are always created on the heap with new. The StringBuilder is initialized with the content hello. The variable sb holds a reference to this single object in memory. Internally, StringBuilder does not store the characters in an immutable way. Okay, so it maintains a character It maintains a character array internally, a mutable buffer that it can modify directly. When you first create it with hello, the internal buffer contains the 5 characters H, E, L, L, O. Okay. Then on the second line we have sb.append wall, right? So append adds the specified text to the end of the existing content of the StringBuilder. The internal character buffer is extended and the characters from the world are written into it. Now the critical point is this operation happens on the existing StringBuilder object, the same object that SB was already pointing to. So no new object is created, so an SB still points to the same object it always pointed to. Okay, so it is just that the content inside the object has changed. After this line, the internal buffer holds hello world. The variable sb is completely unchanged as a reference. It still points to the same object, but the object's content has changed. Okay. Then the third line, system.out.println sb, it will print hello world. When you pass a StringBuilder to println, Java calls the toString method on it, okay, and which converts the internal buffer to a string for printing. We see hello world. Compare this to string. If it had been string as is equal to hello within quotes, then s.concat world system.out.println s would have seen hello, not hello world, because the result was discarded. With StringBuilder, no discarding happens. Okay, the append, it modified the object in place. Okay, then we are going to discuss various key StringBuilder methods. Okay, the first one is sb.insert, and we have 5 comma within quotes comma. Insert inserts a specified string at a specified index position. The index points to where the new content will be inserted. The existing characters from that position onwards are shifted to the right to make room. Okay. The StringBuilder currently contains hello world. Let us map the indices. So index 0 is H, index 1 is E, index 2 is L, then index 3 is L, then index 4 is O, then index 5 is space, okay, and index 6 is W, and so on. So we are inserting a comma at index 5, right? So index 5 currently holds a space. So the space character currently at index 5, it shifts right to become index 6. The comma takes the position 5. So everything after that it shifts one position to the right. Okay. So result will be hello comma world. So length was 11. After inserting one character, it becomes 12, right? The next method is sb.delete. So we have sb.delete 5 comma 6. So delete removes the characters from StringBuilder. The first argument is the start index inclusive. The second argument is the end index exclusive, right? So this is the same inclusive start exclusive end convention as substring. The StringBuilder currently contains hello comma world. We are deleting from index 5 up to but not including index 6. That means only the character at index 5 is deleted. What is at index 5 right now? The comma we just inserted, right? So we are deleting just the comma. The result will be hello world, no comma. Okay, the comma is gone. So we are back to hello world with the space. The next method is sb.replace. So we have here sb.replace 6, 11, Java within quotes. So replace on StringBuilder, it replaces a range of characters with a new string. Okay. Again, start is inclusive, end is exclusive. The StringBuilder currently contains what? It contains hello world. Let us count. So index 0 to 4 is hello, then index 5 is space, index 6 to 10 is world. So index 11 beyond the current content. Okay. So replace 6, 11, then Java, it replaces the characters from index 6 up to but not including 11. That is the word world, right, with the string Java. So result is hello Java. So world is replaced by Java. The string builder now has 10 characters. Okay. Then the next method is sb.reverse. So reverse reverses the entire character sequence currently in the string builder. Every character is mirrored around the center, right? The string builder currently contains hello Java. So reversed character by character, it will become what? AVAJOLLEH, right? So the result is AVAJOLLEH. So note that reverse reverses the entire content including spaces. The space that was between hello and Java is now between J and O. Okay. So the next method is delete sb.delete deleteCharAt then 0. So deleteCharAt it removes the single character at the specified index position. So everything after it shifts left by 1. So string builder currently contains AVAJOLLEH. So we are deleting this character at index 0, which is a. So result will be VAJ then OLLEH. Okay. So length will decrease by 1. So the A at position 0 is gone. Okay. So if we do sb.length here, length next method is sb.length, right? Length. Okay. So length returns the number of characters currently in the string builder as an int. The content that is there in the string builder is currently VAJOLLEH, right? So let us count VAJOLLEH. So that is 9 characters. So length returns 9. Okay. So this is a method on the current state of the content. As you add and delete characters, length will reflect the current content every time you call it. Okay. Then we have sb.indexOf. Okay. O. Right. So indexOf on string builder works the same way as indexOf on string. It finds the first occurrence of the specified substring and returns the starting index. Okay. So if not found, returns -1. So that we have to remember, right? So if it doesn't find it, it will return -1. The content is VAJOLLEH, right? So character O appears at index 4. So counting from 0, V0, A1, Z2 and J2, then we have 3 and 4. Okay. So index of O will return 4. Okay. So space was there at 3. Then chaining, right? So we have string builder chain is equal to new string builder. So let us explain here. So why chaining works with string builder and how it differs from chaining on string. When you chain methods on string, each method returns a new string object. The chain works because each new object is passed to the next method. When you chain methods on string builder, each method returns this, a reference to the same string builder object. Okay. The chain works because you keep calling methods on the same object over and over. Okay. So let me step through this chain step by step. So we have new string builder, right? So we have string builder chain is equal to new string builder. So the new string builder and a new empty string builder is created. So internal buffer is empty here and length is 0. Then we do append Java, right? So Java is added to the empty buffer. Content is now Java and length is 4. Append return this, a reference to the same string builder. Then we have append space, right? So called on the same string builder, the one containing Java, right? So a space is added, content is now Java, then space and length is 5. So return this, okay? And then we have append 21, then called on the same string builder, now containing Java, then space, then 21, okay? Length is now what? 7. Java 4, then space 5 and 2, 1, right? So length is 7 and again it will return this. So then we have insert 4, then we have dash OCP dash, okay, called on the same string builder, now containing Java space 21. So insert dash OCP dash at index 4. So what is that index 4? Let us count. Java 0, then A1, then B2, then A is equal to 3 and then space is equal to 4. The space is at index 4, right? So in the insertion goes at index 4. So shifting the space and everything after it to the right, okay? The content becomes Java plus dash OCP dash plus 21 is equal to Java dash OCP dash 21, okay? So again it will return this reference, okay? The variable chain receives the reference returned by the last method in the chain, this, which is the same string builder object we started with, okay? So system.out.println chain, it will print Java dash OCP dash 21, okay? The entire chain operated on one single object in memory. No intermediate objects were created. This is why string builder is so efficient for building up strings through multiple operations. So now let us discuss string versus string builder comparison. Okay. So string version string s is equal to a, then a s plus equal to b, right? So what happens is that when you write s plus equal to b within quotes, what Java actually does behind the scene is take the string that s points to, that is a, right? So create a string builder, append a to it, and then append b to it. Okay. So and then calls toString on the string builder and creating a new string ab, and then make s point to this new ab string. So just for 1 plus equal to operation, Java creates a string builder internally, uses it, and then creates a new string. Two objects involved just to add one character. Okay. So let us understand very carefully. So now imagine doing this in a loop 10,000s of times, right? So each iteration creates a temporary string builder and not a string. So at the end, you end up with thousands of objects in memory, most of them immediately becoming a garbage. So this is very inefficient. But string builder version is that string builder b2 is equal to new string builder a dot a, then b2 dot append b, right? So one object b2 is created once. Append modifies it in place. No new objects, no temporary intermediate strings. So after b2.append b, the string builder contains ab. One object, done, right? So in a loop of 10,000 iterations, you still have exactly one object, the same string builder being modified each time. Okay. This is why the standard advice is, if you are building a string through multiple concatenations, especially in a loop, use a string builder. If you are just building a string in one straightforward expression, the compiler is smart enough to optimize it. But for repeated concatenation, string builder is always the right choice. Thanks for your time and for taking time to watch this video. See you in the next one. If you got value from this video, please like and subscribe. It genuinely helps this series reach other OCP candidates who need it. Okay. So if you want to practice OCA questions right now, you can go to javalearn.clustermicro.com. Over 1600 questions are there, and there are timed exams, detailed explanations, and free trial available. So OCP 21 practice questions are also coming soon. You can email ab.clustermicro@gmail.com if you want early access notification. So I'll see you in the next video.